Okay, so today we're going to be doing holes within rational functions, and it's going to be a hole within the function here. I'll show you this hole right here. It's a hole within the function. It's special cases with rational functions, and we're going to talk about what this is, how you find it, and how to graph this as well. Okay, go ahead and write this down. Let's begin. So as you can see here, a hole is when you have a factor on the bottom and the top that is common. A hole is solving for x within that factor. So as you can see here, the factor that was common, we solved for x, and x value would be 4. And then we did f of 4, so the value of x equals 4, to find the y value of the hole. And then we have the hole right here. So as you can see, we included the whole coordinates into the f of x, into the domain and range. We added the whole coordinates into the domain and range and their restrictions because it cannot equal the whole coordinates. The whole is not a part of the function, and it's not a part of the x values or the y values of the function. So as you can see, we graphed it here. And it's graphed completely. So for the end behavior, as you can see here, as the graph continues into negative infinity, the y values approach 0 from the underside, so it's going to be 0 with a negative symbol. As it approaches infinity, we see here that it approaches 0 from the positive side, from above the HA. So that explains end behavior for both negative infinity and infinity. As it approaches the VA, from before the values of the VA, so the -5 negative, it approaches negative infinity. And as it approaches the VA from the values after the VA, so -5 plus, it approaches positive infinity. So as you can see here, the entire graph is graphed. We have end behavior and asymptote behavior. We did domain and range. We found the x and y value for the whole, and all of it is complete. So that's graphing holes within rational functions. Again, if there's a common factor on the top and the bottom of a quadratic function and you cross them out, that's the value of the x-coordinate of the whole. So you solve for x within that factor, and that's the x-coordinate of the whole. Once you solve for x at the factor that you crossed out, you input that value into f of x to find the y-coordinate of the whole. And then you should be left with the whole, and you can graph that whole right there, and it should be good. Thank you very much for watching, and have a great day.